Alright, so let's go over some problems concerning functions. So the first one, what are the roots of f of x equals x squared minus 81? So find the roots for that function. The next one would be, what is the domain of h of t equals the square root of 3 minus 7t? And number 3, which regions make up the domain of h of x equals x over the square root of x squared minus 9? So find out which of these regions, 1, 2, 3, and 4, make up the domain. It could be more than one. Alright, so why don't you guys take a minute to do each one. So the first one, you can pause and try it out. Okay, so let's go over it. What are the roots of this function? So f of x equals x squared minus 81. When they say roots, remember what the quadratic roots were. It was the x value or x values that we would plug in to get 0. So in this case, we want the x values that makes f of x equal to 0. So all we need to do is set x squared minus 81 equal to 0. Well, this is a difference of perfect squares, so we can factor it as x minus 9 times x plus 9 equals 0, which gives us the roots x equals 9 and x equals negative 9. These two roots give you f of x equals 0. So those two would be f of 9 equals f of negative 9 equals 0. So those are the answers, 9 and negative 9. Alright, so why don't you try number 2, pause and come back. Alright, what is the domain of h of t equals the square root of 3 minus 7t? So the domain would be all the t values that are possible. Well, we have a square root sign, so we know that no negative sign can be under. So I propose that we find out where 3 minus 7t is less than 0. So less than 0, not less than or equal to, because it can be equal to, so just less than 0. Let's try that. 3 minus 7t less than 0. So we would treat it like an inequality. So we can subtract 3, so we get that negative 7t is less than negative 3. And now we divide by negative 7 to get t is greater than 3 over 7. Remember, we divided by negative, so we flip the sign. So these values of t would make 3 minus 7t negative. So the domain would be everything that's opposite of that. So t is less than or equal to 3 over 7, and that's our domain because those values are possible, and we can check it out. So let's try and see what values here would make sense. So if we make t equal to 5, then we should get a negative under the square root sign. Let's test it out. So 3 minus 7 times 5. So that would be the square root of 3 minus 35, which is the square root of negative 33. And so that's a negative number under the square root sign. So we know that that doesn't work. And now here we can find a number less than 3 over 7. So let's try 0. If we plug in 0 for that t, we get the square root of 3, so it works. So the domain is t is less than or equal to 3 over 7. And it's important to note that you can write the domain in different ways. So that's one way of writing it. You can also write it as, well, if it's less than 3 or equal to 3 over 7, we can say it's between negative infinity and 3 over 7. This bracket here means equal to 3 over 7. So it's between negative infinity and 3 over 7, including 3 over 7. Okay, great. And the reason why you don't put brackets over or right next to negative infinity or infinity is because nothing can ever be equal to that. So always put parentheses. All right, so now let's try the third problem. So which regions make up the domain of h of x equals x over the square root of x squared minus 9? So take some time to try that and then come back. All right, now that we're back, let's check it out. So we're trying to find what the domain is. So we can try out points here, but let's just solve it or use the function to find the domain. So we have h of x equals to x over the square root of x squared minus 9. So now this square root sign cannot have a negative number underneath it, but also it's in the denominator, so it cannot equal 0. So that we know our domain must have this following condition: x squared minus 9 must be greater than 0. And once we solve for this, we know our domain. Another way of doing it is just finding what region cannot be in the domain and then taking the opposite of that, or whatever the leftover regions are. But let's do it this way. So we add 9 on both sides, and we get x squared is greater than 9, and take the square root of both sides. And so now we have x is equal to 3 and negative 3. When you take the square root of a number, you can get the square root as a positive and negative number. That's important to know. So that means that if x squared equals 16, then x equals 4 and negative 4, because 4 squared is 16 and negative 4 squared is 16. So here are our two roots, or our two values, our two endpoints. So if we plug in any of these numbers, then we get 0 for this. So then what's our domain? Since we have two roots here, 3 and negative 3, we need to try out each one separately. Or you can just use inspection to see that x must be greater than 3 and less than negative 3. It's not the case that x is just greater than both of them, because since we got the negative 3, we had to flip signs. But let's actually use the number line to figure this out. If we use a number line, we can just plug in certain points in each region and see which ones work. Well, since we have 3 and negative 3, we put those points here. That's where they go. And if it were 2 and negative 2, then we would put those points there, because that's where the function is 0. So let's try region 1. Let's try the number negative 4. So if we plugged in negative 4 for h of negative 4, what would we get? Let's find out. We would get negative 4 over radical 16 minus 9. And that would be an okay number. That would be 4 over the square root of 7, so that's a positive number. And now we know that that region works out, so we can shade it in. And it's greater than negative 3, so it would be an open circle. And now we can try region 2. We can try negative 1, for example. So let's try negative 1 since it's in that region. And so that would be negative 1 over square root of 1 minus 9, and that is negative 1 over negative 8. So that does not work. So region 2 does not work. So no. Let's try region 3. We can try in the number 1. So let's do h of 1. And we would get positive 1 over 1 minus 9, which is the same thing, so that does not work. And so we know that region 3 is invalid. That does not work. And now we try region 4, and we could try the value 4. So h of 4, what is that? That would be 4 over square root of 16 minus 9, which is what we got in the beginning, which is 4 over the square root of 7, and that works. So the regions that work are the two end regions. So these two with an open circle. So less than negative 3 and greater than 3. And the way to write that would be like this. X is greater than 3 and x is less than negative 3. Alright, or you could use that notation I showed before. From negative infinity to negative 3, exclusive, and then from 3 to infinity. Okay, great. So we went over those problems, and now we can move on to the next topic after this.